Hello everyone, welcome back. Today we learn trigonometric functions. Trigonometry is the branch of mathematics which deals with the sides and angles of a triangle and the problems related with those, right? So it is very important topic. So let's learn the topic measure of angles in this. So positive angles and negative angles. Now when see this is the initial side, okay, this is the terminal side. When terminal side rotates about the anti-clockwise direction, then the angle is positive, and vice versa. When terminal side rotates in clockwise direction, it is a negative angle. All right, this angle measure, okay, so that is nothing but the amount of rotation between the terminal and the initial side. All right, there are two systems, okay, degree measure. So when I talk about a complete circle, complete revolution, which is 360 degrees, so first part of it, I mean, that is the 1 degree. All right, 1 degree equals to 60 minutes and 1 minute equals to 60 seconds. All right, then radian measure, this is new to you, right? Now see, when I talk about this complete circle, this is the center, okay. When the arc, let's say this, I'm talking about this arc subtend the angle over here, okay. Now when we talk about the unit circle, so the radius is 1 unit, okay, the length of the arc is 1 unit, then this angle which is subtended at the center is called 1 radian. All right, so you can say theta is equals to length of arc upon radius, or length of arc is equals to radius into angle subtended, which is measured in radian. All right, okay. The relation between degree and radian, so as we discussed, 360 degree is the complete revolution, which is called 2 pi radian. So pi radian equals to 180 degree. Now I can convert using this. 1 radian equals to 180 degree over pi. Okay. This gives me approximate these values. Alright. Degree and radian. And I can use the formula, okay, to convert degree measure to radian measures or vice versa. Now here some important angles which are converted into degree and radian. So as we discussed, 360 degrees 2 pi, 180 degrees pi. Alright, and these are some very important which you have to remember throughout this chapter. Alright, so 30 degree pi by 6, 45 is pi by 4, 60 degrees pi over 3, 90 is pi by 2, 270 is 3 pi by 2. Alright, okay. Now let's solve some questions based on this. So here comes a very easy question. The angle, we have to find the angle in radian, okay, through which the pendulum swings. If its length is this, so this is nothing but the length, radius is given. So radius is equals to 75 centimeter, length of pendulum, okay, and length of arc. So this is L. L is given as 21 centimeter, right? And we have to find theta. Very easy, right? So theta is equals to L over R. Just now we learned. So I can substitute the values and I can simplify to get my final answer. So divide by 3. So 7 over, I'll get 25 radian. Okay. Alright. Very easy question. Now we have to convert the following degrees into radians. So what we have to use, we have to say degree radian, right? So I can say theta is equals to, we have to use pi over 180 times degree, so 240. And when I simplify this, so I'll get, I can divide by 6, 6, 4, 6, 3. So I can say this is 4 pi by 3 radian. You have to write the unit. Alright, very easy question. Second one, again the same way, okay, pi over 180 times 520, and when we simplify this, we'll get this as 26 over 26 pi by 9, okay, radian again. Alright, then The third one, what I can say, theta equals to pi over 180 times 25. So this gives me 5 pi by 36 radian. Alright. Now the fourth one. Okay. Now understand, here it is degree and minutes. So first of all, I'll just write this as 47 degree 30 minutes. So which is what? Minus I can write outside. So 47 degree and plus 1.5 degree, correct? Because 60 minutes is 1 degree, right? And now I can write this as minus of, when I take the LCM and simplify this, I'll get 95 over 2 degree. Okay. Now I can write theta equals to pi over 180 times minus 95 over 2. This gives me answer in negative. So minus 19 pi by 72 radian. Okay. So negative angle means it is clockwise direction. Alright. Easy. Now let's learn this type of questions. Okay. Degree to radian again. So the first one is 40 degree 20 minutes. So I can write this as 40 plus 20 over 60 degree. Okay. This is in terms of degree now. And now when I simplify this, so I'll get this as 1 over 3 here, and now 40 plus 1 over 3, I get 121 over 3 degree. Alright. Now I got this in degree and I can convert this into radian as pi over 180 times 121 over 3. When we simplify, we'll get 121 pi over 540 radian. Alright. Be very careful when you convert this minutes or seconds into degree. Alright. Now let's solve the second one. Now here minutes and seconds both are there. So first of all, we'll write this as, let me just write this as 48 degree plus 37 over 60. Now we are writing in terms of degree, plus again 30 plus over 60 times 60, right? Because I am converting into degree now. So total answer in terms of degree. And now, so now finally when we simplify this, we'll get 389 over 8 degrees. And now I can convert this into radians. So pi over 180 times 389 over 8. And on simplifying this, this gives me 389 pi over 1,440, okay, radian. So this is my answer for the question. Alright. Be careful when you solve this question. Alright. Now let's learn how to convert the radian measure to degree measure. So you have to use this relation, degree measure equals to 180 over pi times radian measure. Use pi as 22 over 7. Then the fraction part, okay, when you get a fraction part, convert that into minutes or seconds one by one. So when you solve the questions, you will understand what I am trying to say. So let's convert 6 radians into degrees. So I'll use the relation. So we are solving this. So theta is equals to 180 over pi times 6. Okay, now 180 over 22 over 7. So what I'll do, I'll just write 7 times 6. Correct? And now when I simplify this, so we'll get 343 7 over 11 degree. Okay, this is in degree. Now this fraction part. So what I can write this as 343 plus 7 over 11. And now this 7 over 11 we have to convert into minutes. Okay. Now this is what 343 plus. When I simplify this, Okay, so we'll get 38 2 over 11 minutes. Alright, these are in minutes. Now again I have a fraction part, so I can continue by converting in seconds. So 343 plus 38 plus 2 over 11 times 60. Now this becomes in, these are in minutes, okay, and now seconds we have to convert. So what do we get? When I simplify this, I'll get 10.9 seconds, which are approximately, I have to take 11. So 343 degree, okay, these are in degrees, then minutes, 38 minutes and 11 seconds. So this is the answer. Alright, same way you can convert this 5 over 64 radian into degrees. So let's do it quickly. So theta is equals to 180 over, here we'll just write pi over 64 because pi will get cancelled out. So I'll just write 180 over 64, which is nothing but 45 over 16 degree. Now I'll write this as 2 whole 13 over 16, right? So these are in degrees, okay, degrees. Now 2 degree plus 13 over 16 times 60 minutes. Okay, we are writing in terms of minutes. When I simplify, so 2 degree 195 over 4 minutes. Again, we have to write this in fractional form. So let me just use this. So 2 degree plus 48 3 over 4 minutes. Again, we have a fraction value. So 3 over 4. So 2 degree plus 48 minutes plus 3 over 4 times 60, and you'll get 45 seconds. So 2 degree 48 minutes and 45 seconds. So this is the answer for this, right? I hope you understood this, right? Now we have a question where the length of the arc is given, right? This is 3 centimeter. Angle subtended is given as 30 degree, and we have to find we have to find the length of the arc where the radius is given. This is r, and we have to find L. Okay, all right. So we know that theta is equals to L over r, right? So L is nothing but theta times r, where theta is in radians. So what I have to do, theta is 30 degree, which is nothing but pi by 6 radian. Okay. Remember that table which I have taken first. So you have to use this, or you can convert that. Okay, anything is fine. Now L is equals to theta into r. So which is pi over 6 times 3. Correct. So you will get pi over 2, and pi value you have to use as 3.14. They asked us to use that. So 3.14 over 2, which is 1.57 centimeter. So this is the length of the arc. Easy question, right? Perfect. Alright, now interesting question. So we have to find the degrees and radians at the angle between hour hand and minute hand at clock 3:30. Now one complete revolution for 12 hours is 360 degree. So what I can say, the angle by hour hand in 12 hours, which is equals to 360 degree. So now 3.5 hours. So 3 hour 30 minutes, which is equals to, this is nothing but 3.5, which is 7 over 2. So what I can say, 360 over 12 times 7 over 2. And when we simplify this, we'll get 105 degrees. Correct? Same way for minute hand. So 60 minutes is one complete revolution, 1 hour, right? So the angle by minute hand in 60 minutes, right, which is equals to 360. So in 30 minutes is equals to 180 degree. So what I can say, the angle, required angle, right, equals to 180 degree minus 105 degree. So this gives us 75 degree. So the answer in degrees is 75 degree and in radian. So 75 times 5 over 180. So this gives us 5 over 12 radian. Alright, perfect. Now again interesting question. Okay, the minute hand of a watch is 1.5 centimeter long. So that's nothing but the radius you have to consider. So 1.5 centimeter. Now how far its tip move in 40 minutes. So the angle equals to what? 40 over 60, correct? 40 times 360 over 60. So this gives us 240 degree. Now remember that here theta equals to L over R, where theta is in radian. So we have to convert this into radian. So 240 degree times 5 over 180. When I convert this into radian, I'll get 4 pi by 3 radian. So now we have the value of R, we have the value of theta, so we can find L. So L is equals to theta into R. This is nothing but 4 pi by 3 times 1.5. Put pi equals to 3.14. They asked us to put that. And when you simplify using those values, so 4 into 3.14 into 1.5 upon 3. So you'll get the length of the how far, right? So that is nothing but the distance. So 6.28 centimeter, correct? Alright. Now here we have to find the degree measure of the angle subtended at the center of the radius. Radius is given as 100 centimeter, right? And the arc length is given as 22 centimeter. So we have to find theta. Now theta is equals to L upon R. So let's substitute this value. So we'll get 22 over 100, right? This is 11 over 50 radian. Now we have to convert this into degrees. So 180 over pi. So I'll directly write these values, okay, to simplify this. And when I completely simplify this, we'll get 126 over 10, or I can write this as, this gives me 12, right? 3 over 5. These are in degrees. Again you have to convert this into radians using the minutes and seconds into using the same technique. So 3 over 5 times 60 minutes. So what do we get? 12 degrees and 36 minutes, right? So the answer is 12 degree 36 minutes, correct? So this is the angle subtended by this arc, okay? All right. Now here in this question, see the circle of the diameter. So diameter is given as 44 centimeter. So we can write the radius as 22 centimeter. Alright, the length of the chord is given as 22 centimeters. So let's understand. See, what is it? This is the center. Okay. Diameter is 22. Radius is 22 and the length of the chord. This chord is 22. So this is the equilateral triangle. Means all angles are 60 degree. So this angle is 60 degree. Alright. So we got the theta. Theta is equals to 60 degree, which is nothing but pi by 3 radian. Alright, so we have this value and we have to find the length of the minor arc. So this we have to find. Alright, so length is equals to theta into r. I can substitute this value pi over 3 times radius, which is 22. And now I can use the uh, value of pi is 22 over 7. So I can say 22 over 7 times 22 over 3. And this gives me 484 over 21 centimeter. So this is the length of the minor arc. This. Okay, this. Alright. Easy question. Now here, very interesting question, right? So the person is reading, okay, the letters at angle of 5 minutes. Okay, so the theta is given as theta equals to 5 minutes. Now I have to convert this into degrees first. So 5 over 60, which is 1 over 12 degree. And now I have to convert this into radian. So 1 over 12 times pi over 180. Right? So these are in radians. We'll just keep this as it is because we can cancel out. Okay. Now uh, this distance is given, so which is nothing but the radius. So r is equals to 12 meter. And you have to find the height of the letter. So L. Okay. Now L is equals to theta into r. So this gives me 1 over 12 times pi over 180 times 12. I can cancel out 1.7 centimeter. Alright. So the height of the letters is 1.7 centimeter. You have to write your final answer. Now, very interesting question. Okay. So angles of triangle are in AP. So let the angles are, let me write. Let the angles are A minus D, A and A plus D. Right? Remember, we have already learned this. So I'll get 3A is equals to 180. So A is equals to 60. Correct? So the angles are 60 minus D degree, then 60 degree and 60 plus D degree. Alright. Minus D degree equals to 60 plus D degree times pi over 180 radian. That's equals to 60 over pi. So what I can write, let me just write this way so you can understand without any confusion. So 60 plus D times pi over 180 equals to 60 over pi. Alright, so this is given to us. And now we have to simplify this. Now make this simple, okay. So 60 minus D over 60 plus D, I can take pi over 180 on the other side. Pi will get cancelled out. 60 and 180 will simplify by 1/3. And now I can cross multiply and I can find the value of D. So 60 times, 60 minus D times 3 is equals to 60 plus D. And now what do we get? D is equals to 30. So the angles are the angles are 60 minus 30, which is 30 degree, 60 degree and 90 degree, right? So very interesting question, right? Perfect. All right, now again interesting but easy question. So they have given that the horse is tied with a rope, okay, and that subtend the angle of 54 degree. Alright, and this length is 88 meter. So you have to find the length of the rope, which is r. Alright, so we are given L is equals to 88 meter, theta is equals to 54 degree. Now I have to convert this into radian. So 54 pi over 180 radian. And now we have to find the r. So r is equals to L over theta. So this gives me 88, correct, over 54, 22 over 7. So 7 I'll keep up, and 180. So again 180 goes up. So 93.33 meter. So this is the length of the rope. Alright. Okay. Now here in this question, if the arcs of the same length in two circles subtend the angles, so angles are given and we have to find the ratio of their radii. So we'll use this. See, length of the arcs are same. So L1 is equals to L2. Now this is what theta 1 R1 is equals to theta 2 R2. Now we have to find the ratio R1 to R2, which is nothing but theta 2 over theta 1. Be careful, okay, while you write this. Now theta 2 is 75 degree over 60 degree. See, when I convert this into radian, I'll get this, correct? But I can easily cancel this out, so I am not going to find this separately. I simply just write my answer as 5:4. So this ratio is 5:4. Alright, so you have to write the required ratio is 5:4. Alright, very easy, but see, very easy, don't make it complicated. Alright, okay. Now here the perimeter of the certain sector. Sector is nothing but, see, when you talk about the circle, this is the center, the pizza slice, okay, I mean this is called the sector. So the perimeter is given equals to the length of the arc of the semi circle having the same radius, perimeter, right? So see, if the radius is r, correct, this is r. Now they are saying and this is L. So perimeter is what? Perimeter of the sector. Perimeter of the sector equals the length of the arc of the semicircle. Length of the arc of semicircle. R plus L equals the length of the arc of the semicircle, because it is a half perimeter. Okay. Now here the length is theta times r. This is equals to pi times r. Now everywhere I can cancel out by r, so I can say that 2 plus theta equals to pi, correct, or I can say equals to pi minus 2. These are in radian and we can find, see, express the angle of the sector in degrees, minutes and seconds. So that's why we have to convert this into degrees. Okay, so what I can say, pi minus 2 times 180 over pi, distributive property. So pi times 180 over pi minus 2 times 180 over pi, correct. Here I'll get 180 degree minus. Now this I have to convert into degrees and minutes and seconds. So 180 degree in degree, 32 seconds, 44, I mean for 32 minutes 44 seconds, and this gives me the final answer as 65 degree, 27 minutes and 16 seconds. So just convert this. Okay, we already learned that, so I'm not making the video lengthy. I hope you understand this topic, measures of angles. If you have any doubt, let me know in the comment box. I'll surely help you out and practice these questions. So these questions are very important as per the competitive exams. Alright. So please solve that. And if you like the video, share with your friends. Thank you for watching.